Okay, so the next problem in the lead code we are solving is combination sum 3. Okay, this is third sum. So basically what is being asked here is we'll have to like we are given a value k, okay, and we are given a value n. Okay, we need to among in the range of 1 to 9, 1 2 3 4 5 6 7 8 9. Okay, we'll have to generate a combination of three numbers. Okay, it can be 1 2 4, 1 2 3, 1 2 5. It can be anything. Okay, but the condition is the sum of it should constitute to this. Okay, 7. Okay, so basically what we are trying to do here is we have to try all the possible combinations and also finally take the sum of it and see if it is matching. If it is matching, that's a valid combination. If else, it's not a valid one. Okay, so now what is happening here is, so basically we'll have to try all the combinations, right? When it's a combination, basically like we'll have to go with the backtracking, correct? Like we can use the backtracking method to try out all the combinations here, right? And when it's a backtracking, to be in simple term, it's a recursion again, like, right? Like whatever the combination we are trying, we'll be using the same logic to recursively perform the same logic, right? So that is one thing. Like we got to know that it's we are asking to do is a combination and we'll have to go with the brute force thing, and we are going to do it via backtracking method, right? And also whenever we get a problem of the backtracking, right, it like we'll be trying to build a path, right? Like we'll be going to try the combination 1 2 3, and 3 didn't work, like we'll have to go for the next one, 1 2 4, and we'll be building our paths, correct? So it will be easy for us to write a recursive function when we easily denote it in terms of the tree. Okay, like it will be clear for us like what to send to the next recursion. Okay, so for example, let's see what is being asked here is in the range of 1 to 9, right? 1 to 9, we will have to find out a sum of 3. Like, I mean, we'll have to build a list of three numbers, okay, which constitutes the sum is equal to 7. That is the first example, correct? So how, if we are going to represent in terms of the tree data structure, like, I mean, that will be easy for us to backtrack. Okay, so what will happen, first thing is I can pick the first number 1, correct? And maybe in the next iteration I can pick the number 2. Okay, like it can be 1 2 3, that's also valid, 1 4 5, 1 6 7, and also like 2 4 5, 2 6 7, everything is valid, right? We'll have to try all the combination. So the starting number can be anything, right? It can go up to 9. Okay, and again once this is taken, what will happen, right? Like in the next what are we left with? Like let's say that if I pick 1, I am left with from 2 to 9, correct? So in the next iteration, what we are going to do is we are going to pick 2 till to 2 to 9, correct? This is our range, correct? So now what it will how will it will help is, so now we know, okay, once we entered it, what we are going to do is every time whatever the index whatever we get, we are going to increment this. Okay, this is what we are going to send it to the next node for the calculation. Okay, so this will help that way. And also whenever we say that the backtracking method, right, basically whenever we are using the tree kind of things, we'll be also sending out the path. Okay, and we are not caring about the condition yet. Okay, we'll come to that return condition and everything, like what is the condition and everything. But for now, let's do like what are the possible combination that we can build here first. Okay, right? On top of it, we can say that if it is a valid or not, we can go with that. Okay, so now we know that one is already picked, so we have two more gaps, right? We have to fill the three number size, we have two more gap. Okay, so we still have to proceed. It can be two, next number can be 2 or 3 or 4, anything, right? Again it will have kind of n minus 1, like we have picked one already, so we'll still have those many combinations, correct? It can be 2 3 4, anything it can be. Okay, okay, so now we are here. Okay, we have already picked the two numbers. Okay, next what it will be, like we already picked 2 here, it means that for the next iteration, as we discussed, right, n plus 1 it would be, so I can go for 3 comma 9, right? This is how we can picturize like what needs to be sent to the next node, basically, right? Here if I pick 3, okay, let's say that here I had picked 3. Okay, like let's say that in some path, let's say instead of 2, right, I picked it 3. Okay, so what will happen, and for the next iteration, what I am going to send here, I am going to send 4 comma 9. Like, I mean, I will be sending for the next array, right? We already done solved the remaining one, we'll be sending this. Okay, so once we are done with this, right, like, I mean, if you are able to picturize this, we'll get to know that okay, we have to try all this combination first, correct? And again we'll have to do whatever that is remaining in the sub tree node, this is belongs to this one. Okay, we in everything in this we'll have to try again this one. Okay, and out of this we'll have to try again this, so it's like kind of we are doing the same things again and again. Okay, so we are going to break down this into multiple, this like for loop, right? We can just, for the first thing is, we can just have a for loop, like, I mean, iterate through 1 2 3 4 5 6 9, and again we can have a for loop, correct? Like I mean, to be precise, like I mean we can have a for loop to iterate through 2 till 9, and again we can have a for loop like 3 to 9, but that's not a, like a feasible solution for us to write, right? We don't know like how many loops we are going to write, right? So that's why we are going to use a recursion here. Okay, so now okay, so let's come to the end condition now. Okay, so now we have built this list. Okay, like do I need to go to 4? Like that we'll have to check, right? Like, or else we'll be keep on going, right? Like I mean we'll be building our list and all. Like we need to have some exit condition somewhere. Okay, so at each node we'll perform some calculation. Okay, so what we'll do is we'll see like what is the given condition. So, like there will be one exit condition always, right? Given in the problem, the given condition here is k should be 3. Like I mean the size of the list whatever we are building, it should be 3. Like I mean here size is nothing but number of nodes, right? 1 2 3. Okay, we have reached. Like I mean when we are passing 2 comma 9, if we are will be also be passing the paths actually, like what has been already covered here, it will be empty, right? Whenever we're doing the calculation we didn't have anything, it will be 1. So for this it will be 1, and it will be for this 1 comma 2. And when we go to the next one, like when we try to do for the next one 4 or something, we'll see that 1 comma 2 comma 3 has been passed from the previous iteration, and k is equal to 3. It is already matched. Okay, it is already matched and we don't have to do anything. That will be exiting, we'll be exiting from there. And one more condition is it should be sum should be 3, sum should be equal to 7, or only in that condition we'll be making it as valid, right? We'll be checking that also. Like we'll be checking that and we'll be adding it to our final result and we'll be exiting from the loop. Okay, so once this is done, okay, the length is we have reached a 3, so we will be coming out of that recursion. Okay, we won't be proceeding further. We can build a number of combinations still, but we are not going to do it because we don't need it, right? The sum is done here. So we'll be jumping to the next one. Like I mean once we come out of the recursion, whatever that is pending, right, that will be taken care. Basically, like I mean we should be having some solid grip on recursion, so that will help us in solving this problem easily. Okay, so if you just check the code, right, code looks simple actually. So what we'll have to do first thing is to revise here. So when we got to know this is a combination problem. Okay, and the next thing, when you say combination, it's actually we can solve it via backtracking, right? Backtracking is nothing but a recursion. Okay, and when we say recursion, right, like I mean it will be in the backtracking problem. Like basically we will be trying to identify what are the combination, and also we can say it's a combination of paths. Let's say that if you want to go from one place to another, right, you can go this way. Like I mean best possible paths we'll be finding it, right? So that's why, like I mean we basically will be making use of a tree to analyze here. Like I mean decision tree. Okay, like to go this way, like what will be the if I go this way, like if the condition will be met, all these things we'll do. Like visualizing, and to understand it better we can have one tree data structure written, and we'll understand what is the current path that is already traveled. The current path is nothing but the combination that we have tried so far. Okay, and we will get to know the path, and what will be also knowing the list of numbers there, right? So okay, now we are good there. So we understood how we can come to this, right? Why backtracking, why tree data structure and all. So once we write down that tree data structure, now we know what needs to be passed and all. Okay, so at foremost thing, when we start, we don't have anything in our path, like that's a root node, or we can say that's an empty, right? We don't have any path, and we'll be starting from 1. Like I mean 1 to 9, right? Like we'll be range is 1 through 9, so it will be 1. Okay, so whenever we enter, for now let's just ignore this exit condition. Okay, we will have to try our combinations, correct? We'll be ranging from 1 to 10. We'll try our backtracking path. Okay, so we got 1 here, and for the next one we'll have to send the adjacent node here, correct? I plus 1, like I mean path will be become what initially it was empty. We'll add the 1 to the path and we'll be sending to the next one, just like we discussed here. We'll be sending the path, right? Like the previous one, here it was empty, here it was 1, all those things, right? We'll be sending that to the next one. Okay, this is an empty, and we'll be sending the next one. Okay, we are not actually updating it, but we just want to let the next recursive function to know what was the path previously. Okay, that was the one thing. And also from where you can start your combination. I have picked one already. You need to start from 2 second index. Okay, that's what it's about. So we'll be asking the next index. So when it comes to the next one, right, so we already built a path like 1. Okay, 1, and we have sent the next index, that is 2. So once we come here, let's ignore this for now, and we have sent the 2 as the correct index, right? So and we have, so far we have built the path as 1, right? And we'll start our loop with that 2 starting from 2 now. So we'll be again updating our path. It will be like 1 comma 2. Okay, and again it is a backtracking, so we'll be going there. Like I mean it will be recursive function. We'll go again, and we'll at some point we'll picking the 1 2 3. Like I mean in the next iteration we'll be picking 1 comma 2 comma 3. Okay, and the finally, like, okay, we are building the list, okay, like we are trying out all the combination, but we do have some condition for that, right? We don't like 1 2 3 4 1 2 3 4 5, like we should not be doing that. There is a condition that length should be k, like, I mean, you should not exit that. So once we reach that, we should stop that path. Like, I mean, it's saying that we have reached the end of the path, we shouldn't be continuing further in that route, we'll be taking the different route now. So okay, once we reach that k, and then if we take the sum, like, I mean, there are two conditions, right? One is this one, which k should be this. If they just ask to get it a combination, right, we just say that combination of three, we can just stop here. But they asked us to also, this should be a sum of sum should be equal to n, right? We'll be taking a sum. Okay, it means that it's a valid. If it is equal to sum, will be valid, else will not consider anything, will be returning it. So it means that it can backtrace to the previous path, and it can start from there. That's it. Yeah, so yeah, that's it actually. Like, I mean, to summarize, when it's a combination, just go with the recursion, and just have some understanding how this recursion works. And okay, to just for understanding how this path and everything will be analyzed, and what needs to be sent to the next recursion, just write it a tree data structure by yourself, so it will be easy to analyze, and what needs to be sent to the next one actually, right? So yeah, that's it. Thanks.